For the second half of this lesson, we're going to do something called cube roots instead of square roots. So let's talk about our perfect cubes. Let's list them all out. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Go ahead and pause the video and fill in the rest of these perfect cubes. So you should have all these perfect cubes filled out. Again, our process is going to be very similar to square roots as we did with cube roots. Our trick is going to be divide by our perfect cubes. And so my very first number here is 875. I'm going to start by dividing 875 by my list of perfect cubes. 875 divided by 8 doesn't work. 875 divided by 27 doesn't work. 875 divided by 64 doesn't work. 875 divided by 125 finally does work. 125 and 7 are my two perfect cube factors. So let's break this down. I'm going to have that cube root symbol has the little 3 in there. And I'm going to have 125 times 7. 125 is a perfect cube, so it gets to break out of that little cube root jail. So a cube root of 125 is 5, and I'm left with the cube root of 7 underneath. Let's do the same idea for this next one. 500, I'm going to divide it by my perfect cubes. 500 divided by 8, 500 divided by 27, 500 divided by 64, 500 divided by 125, and I end up with another 125 as a factor. That's funny. 125 and 4. So I'm going to break this down into 125 times 4. 125 is a perfect cube, so it gets to come out and become a 5. I'm left with the cube root of 4 underneath. The last one, 32. I'm going to divide by my perfect cubes. 32 divided by 8. Already I have a perfect cube, right? 8 is the perfect cube of 2. So I can break this 32 down into 8 and 4. 8 times 4. My 8 gets to come out, and it's a 2. And I'm left with the cube root of 4 in my answer. See if you can do 4, 5, and 6. Oh, see if you can go ahead and start 4, 5, and 6. 64 is a perfect cube of 4, so my answer is just 4. And then 108 can be divided by 27. So I broke it down into 27 and 4. This 27 can come out of my perfect cube because it's a perfect cube. And when it comes out, it's a 3. And so I have 4 times 3 cube root 4, which in other words is just 12 times the cube root of 4. And the last one, 7 times the cube root of, oh, whoops, this is a typo. There should be another 0 there. Your paper should have another 0. The cube root of 1,000, which 1,000 is, in fact, one of my perfect squares. So I'm going to have 7 times 10, which is 70 as my final answer. Let's go down and talk about some variables, some really quick hints. With cube roots, instead of dividing our exponents by 2, we're going to divide our exponents by 3 because we need to take 3 out of our cube root. So the cube root of x to the 3rd is x. The cube root of x to the 6th is x to the 2nd. I could keep going and doing the cube root of x to the 9th is x to the 3rd. So we're dividing by 3 essentially when I'm taking the cube root of something. So when I have the cube root of 162 x to the 3rd, let's break down this 162 by perfect cubes. 162 divided by 8. 162 divided by 27 is 27 and 6. So 168 divided by 27. I'm left with, 162, sorry. Cube root of 162 can be broken down into 27 and 6. And x to the third is a perfect cube. So the 27 gets to come out and the x to the third gets to come out. And I get a final answer of 3x cube root 6. Let's try the next one, 216. 216 divided by my perfect cubes. 216 divided by 27. Oh, that's perfect. I should, 216 divided by, oh, 27 and 8 are both perfect cubes. We should probably divide by something bigger because I'm going to have to redo that. Okay, 216 divided by 64. Wait, 216 is a perfect cube. 216 is a perfect cube. That makes sense. 216 is a perfect cube because it is the perfect cube of 6. So we can break this down. 216 can come out. X to the 12th is also a perfect cube because when I divide 12 divided by 3, I get 4. So when I take both of these out, I end up with 6x to the 4th. What I'm left with inside is y to the 5th. Now, y to the 5th is not a perfect cube, but I can break down that y to the 5th. Y to the 5th can be broken down into y to the 3rd and y to the 2nd. As long as they total up together to equal that, they are the same equivalency. So that I'm going to go ahead and break down. 6x to the 4th stays outside. I have my cube root of y to the 3rd times y to the 2nd, and I can take out that y to the 3rd. So my final answer is going to be 6x to the 4th y cube root y to the 2nd. Very funky. A very long answer. And let's do number 3. When I break down 448, what perfect square can break that one down? I should get 64 times 7. So 64 times 7 is 64 can come out. This x to the 7th, I'm going to break it down into x to the 6th is a perfect cube, and x would be left over. Y to the 4th, I'm going to break it down into y to the 3rd as a perfect cube, and a 1y left over. So that 64 comes out, x to the 6th comes out, y to the 3rd comes out. So I get 4x to the 2nd, y to the 1st, outside of my cube root symbol, and left underneath my cube root symbol is this 7xy. Gosh, I don't have much room there. And my last example, 108, we actually did 108 right above here. We know it can be broken down into 27 and 4. So I'm going to break down this cube root into 27 and 4. A to the 7th, I'm going to break it down into a to the 6th and a. B to the 3rd is already a perfect cube. C to the 2nd really can't be broken down into perfect cubes because there's not even 3 C's left there. So this perfect cube gets to come out. A to the 6th, that perfect cube gets to come out. B to the 3rd, that perfect cube gets to come out. The 4, the A, and the C to the 2nd are all going to stay in. So 27, when it comes out, it's a 3. A to the 6th, when it comes out, it's a to the 2nd because I'm dividing by 3. B to the 3rd, when it comes out, it's just b or b to the 1st. And then the things left underneath my cube root are 4a and c to the second. Nice big long ones. That is it for the cube roots, and you have lots of practice on the next page.